This is my long-awaited BBF Combat Agent Parameter Analysis video. My name is Precious Wally. So first, I want to start with an introduction to BBF character parameters and what is the deal with this whole dilemma. So first of all, for those that don't know, BBF stands for Border Briefing Files. It's a very detailed and complete encyclopedia that describes Ashihara's World Trigger universe. Now, for every single agent that is documented in the BBF, there are parameters for each character that kind of describe that combat agent's ability in combat. And so, as you could see, this figure on the left that I'm circling right now with my mouse is a description of each character's parameters. But these are actually extremely vague and confusing and have been debated by a lot of viewers of Ashihara's World Trigger manga and anime. What do they stand for? What do they mean? This is poorly understood because these parameters are described to be vague and confusing. So essentially what I wanted to do is give you an example of what these parameters look like in the BBF. They are graphically represented like this, and this is an example for Captain Arashiyama's page. If we blow up this figure, you can see that the parameter space is defined by 8 parameters. Trion, attack, defense and support, mobility, skill, range, command, and special tactics. And these all sum up to create a total that quantifies Captain Arashiyama's skill in combat. Now, we really need to ask then, what do these numbers mean? Because the BBF makes it very vague and confusing. So we should create a standard to formally define this ourselves. And in order to do so, I want to take the time to formally and mathematically define these BBF parameters. I know math isn't everyone's interest, so I'll go through this really fast, but I have to at least set a groundwork for mathematical definitions in order to then actually explain the details to how we can understand BBF parameters. So I hope this will seriously elucidate what these numbers actually represent. So first, I want to define a random variable x. That's a function that assigns a real value to each outcome of an experiment. I also want to define what a parametric distribution is. It is an assignment of a random variable's probabilities for different values of x. For example, you might have heard before that your exam papers, when you take a test, their grades are normally distributed. In this case, your random variable x is a test, and your test can take some real value outcome, but we don't know what they are, right? There's a random mechanism causing that, but overall, we can say that these are normally distributed. That is, usually not too many students do extremely well, and not too many students do extremely poorly, but most students do somewhere in the middle, so scores are normally distributed. Now, you could see here that depending on the values of sigma squared and mu is this U looking thing, and sigma squared is this O squared looking symbol. Depending on what numeric values these symbols take, the shape of the distribution changes. Now, these symbols are called parameters. Mu and sigma squared are parameters, and their values change the shape of the distribution. So now I actually wanted to propose the following novel distribution to model an agent's combat abilities. I define the B distribution as a distribution for a character's combat ability, which is a random variable x, and there are 8 parameters that will define the distribution for B. And these parameters are Trion, attack, defense, mobility, skill, range, command, and special tactics, just like it is said in the BBF. And I have matched up all of these parameters with their definitions in the BBF. So this is indeed representing what the BBF is talking about. But now, here's another thing. In real life, we never know what the true value of a parameter is. Mathematically, we can't know what a parameter is, but we can estimate it. We call an estimate of a parameter theta hat. Also, theta hat is a statistic, which is noted by the letter T. Now, Theta hat, in this case, I will define as a sufficient statistic. And a sufficient statistic is formally defined as some estimate theta hat being equal to t, which is equal to r times x. That is just saying this statistic, t, is a function of the data, x. And so the point that I'm trying to say here is that the estimate theta hat is a function based on the combat data that Border collects on each of their agents. So what is happening is we don't just magically know what the value of these parameters, theta, are, but instead every BBF character parameter is not a true parameter, but it is a statistical estimate of the parameter based on combat data that Top Brass collects. So then that question is, what are the values for these estimators? Well, we know that these estimators are rounded to the nearest natural number for the purposes of being displayed in the BBF, but they might not actually themselves be values that are natural numbers. But for now, we say that the theta hat estimate is in the set of natural numbers. So that being said, I actually wanted to say that the function taking combat data into an estimate for the parameter is a black box. We don't know how Border's Top Brass is compiling this BBF, making this huge encyclopedia and document that is documenting all of the stats of a combat agent. We don't know what functions are turning the combat data x into the parameter theta that is then back modeling into each character's combat ability. So for that reason, we have to guess what the functions are, and we can make an educated guess. So this gets back to what I was doing earlier. Again, here are all of the BBF parameter models. Theta, these are not estimates. These are just the theta parameters. But now, here, I propose that each theta, such as theta Trion, can be approximated by theta hat Trion, which is the estimate for Trion. And each parameter has their unique estimate, and I have created equations for all of these. For example, Trion here is a maximum of the characters, Trion, etc., etc. So let me break this huge blackboard of equations down one by one. So let's start actually with Trion. There's Trion, attack, defense, mobility, skill, range, command, and special tactics that we have to talk about how these equations came to be. So again, the BBF defines Trion just as Trion level. And so a good measure of an agent's Trion level is their maximum Trion, because Trion can be depleted from day-to-day usage. So the best measure of it is one that is completely non-random. And so that best measurement is the maximum of an agent's Trion. Now, the attack stat, the attack parameter is the ability to inflict damage on enemies. So I argue that when the BBF says that, ability suggests the sum of instances of one's performance, right? You do this attack and this other attack. These are different instances of performances, right? And you can think about performance as a random variable as itself. Now, central limit theorem is a very powerful theorem in mathematical statistics that states that the summation or that's continually adding up random variable after random variable, right? So the summation of random variables are normally distributed with these types of parameters. So ability is in itself normally distributed. A good measure of a normal distribution's central tendency is, you've probably heard of the mean or average, but one that is better that a professional organization would tend to use over the mean is the median, because the median is less likely to be affected by skewed data points. Thus, ability is an average score. But as we said, ability as an average score, an average is the mean. Median is a better measure of central tendency. And so therefore above, I have said that attack is actually is estimated as the median attack of a character's performance as its ability to inflict damage on enemies. The same thing can be said for defense because the BBF defines defense parameter as the ability to defend and support allies. So as I said before, ability is an average score. Average is mean, but median is a better measure of central tendency that a professional organization would tend to use over the mean because it is not moved around or affected by skewed data points. Okay, now for mobility. Mobility, I also say, is kind of estimated by the median. And the reason why I say that is because it's a speed of movements, suggesting that all movements are being taken into consideration. And as said for before, that data being connected, that data being taken down, right, for movement, when you are having many instances of movements, they are normally distributed. So it is best estimated with the median. But we want to actually add a constant factoring for the effects that mobility influencing triggers can influence this mobility estimate, right? What I mean by this is, in general, all grasshopper users have at least 8 speed. At the same time, we also know that our only known Skanda and Idaten user, which is Kuroe, she has a speed stat of 10, which is humanly impossible, given that we know all of the different speed stats, mobility stats of different users through their BBF displayed stats, and nobody has a stat of 10 without having a trigger that can boost their mobility. So therefore, I argue that mobility is a additive, or the estimate of mobility parameter is a function of both its median and a constant based off of the mobility influencing trigger. And we don't know what the constant is, but we know that it is a factor that plays into a character's baseline mobility. Now, let me go to skill. Skill is described as the accuracy and precision of attacks or blocks. If we take this word literally from the BBF description, that is, we add the accuracy of attacks, accuracy of blocks, precision of attacks, and precision of blocks, all weighted by some unknown constants, right? Added together. So that's for skill. Now we go to range. The range parameter is actually more complicated and interesting to talk about. I would define it as a constant based on the weapons or offensive triggers that a agent is equipping, plus their skill parameter multiplied by their skill parameter, added by their skill parameter multiplied by a very small constant. And so when you see this length of firing range based on skill or weapon, this equation is kind of adjusting for that line based on skill or weapon. When taken literally, firing range is a function of the weapon an agent equips in their trigger. In addition, right, both what weapon an agent equips as well as their skill, which is the skill parameter estimate. We observe that the ranges are quite constant across offensive trigger types, though. Right, so for example, all Senku Kogetsu users, if they don't have other ranged triggers, they're just using Senku Kogetsu, all of them just have 2 range, right? So these are extremely constant across offensive trigger types. Thus, CS, right, the constant before the skill estimate must be a very small number. That is that the skill is not weighted as much as the weapon in terms of its quantitative lendings into the range estimate. Now, because we observe that range is quite constant across offensive trigger types, the contributions due to various offensive triggers in itself is probably not some multiplicative function, but it is probably in itself a constant. And so let's discuss the equipped triggers' contributions to firing range. We see some patterns. For example, Scorpion users have a range of 1, but Scorpion users with access to Mantis have a range of 2. All Kogetsu users with Senku and no other ranged triggers or other trigger types equipped have a range of 2. Now, ray gust users with thruster equipped have a range of 2, which is accounting for the range of a thrown ray gust and thruster. Shooters have a range of 4 to 5, with Ninomiya being an exception, having a range of 6. So this suggests that uniquely for shooters and not other weapon types, Trion is actually used to estimate range. So this equation would not be complete when considering shooters. But at the same time, though, Ninomiya's Trion is very high and it is quite an outlier. And at the same time, there is actually a basis for Trion lending to having farther range for a shooter or even gunners too. But mostly for shooters because they're able to actively change the range and power of the cubes that they generate, right? They can control those things. Whereas for gunners, these things are usually preset. Now, all handgun gunners not named Yuba have a range of 3. All shotgun gunners have a range of 3. All AR gunners, or almost all AR gunners have a range of 4. Now, when we talk about snipers actually have varying ranges. And so you could say, if you were a Bayesian or looking at statistics in a Bayesian framework, we could say that this range parameter in itself is not a single value, but it is a distribution. It in itself is a random variable that exhibits heteroskedasticity. And heteroskedasticity means the ability, when a distribution does not have homogeneous variance across all values. Now, this is because snipers usually use egret as their primary offensive trigger, and egret's range actually scales off of its user's Trion levels. So on average, a sniper with egret has a range of 7. But on average, a lightning or ibis sniper without egret has a range of 6. Now, in most circumstances, all-rounders take the range of the offensive trigger type that provides them with maximum range. This is a contentious point and is arguable. There are critics that will mainly point to exceptions like Utagawa and Arafune. So therefore, there is an argument that for all-rounders or people with multiple weapon types, the offensive trigger type with maximum range sometimes is not adopted, but an average or some measure of central tendency is instead used. But I would tend to think that it is more so a measure of maximum range. Okay, now command in and of itself, I define here as a random variable of situational assessment plus a random variable of leadership. That's because ability to assess a situation and lead a squad is what the BBF defines as the command parameter. So the thing is, we can safely assume that these two things are random variables that are mutually exclusive, and so we can add these two random variables together. This kind of gets into set theory. Now to special tactics. The special tactics parameter is described in the BBF as the proportional frequency of employing original strategies. I'm paraphrasing here, but it's an accurate paraphrase. When taken literally, this is a fraction, which is the number of times an original strategy was used by a certain user, divided by the number of times a strategy was used by the user. And so therefore, this is a proportion. I hope that has given a lot more greater insight and mathematically rigorously defines what these numbers actually means. I hope it's really clear and less confusing now. And thank you very, very much for listening. Thank you very much.